So in this today's session, I want to talk about honeypots because it's a topic that's existed for a very long time in security. There's many different ways you can use it. There's ways of using honeypots that can be dangerous, right? Like you don't want to attract the bears, you only want to detect them. You don't want to cause more issues for yourself. And there's different ways the honeypots can be used. So I think this is going to be useful to be sure we're using the same terminology when we're talking about these types of features. So according to Wikipedia, honeypot is a computer security mechanism that's set to detect or in some manner counteract with unauthorized use of an information system. So what that means is you build a system with the intent of detecting an attacker or tricking an attacker into doing something. That can be very simple. For example, I could, install SSH on a server and then create a bunch of user accounts with really weak passwords, and then I wait to see if anyone is able to break in, and then if they are, block their IP addresses from our network and all that. That's kind of like the original idea of a honeypot, but that can also be very noisy, right? Like in the end, if they broke in with a really weak password, why don't you just make sure your production systems don't use weak passwords, right? Like instead of tricking people to log into that. Because one of the problems is there's so many attacks going on the internet that could generate a lot of noise. So you've got there's a bunch of different types of honeypots, but the main ones like that we talk about day to day, you have research honeypots. Those are placed usually directly on the internet, on different cloud providers, or to try and get a sample of the traffic that happens on the internet. And those will gather a lot of data. So you wouldn't alert on those, you use them to build, aggregate trends. So for example, when a new vulnerability comes out, maybe you want to know, are people exploiting it already, right? So I've put a screenshot here of Grey Noise, which is a security company that uses a lot of different techniques, including honeypots, to get their data. And this is what they call the Grey Noise trends for exploitation of the latest Atlassian Confluence server bug that was disclosed a few weeks ago. Actually, I think it was disclosed 11 days ago on June 3rd, which you can see there. And already on June 4, they could detect 4 different IPs on the internet attempting to exploit that vulnerability. So these honeypots, like really wide deployment, a lot of volume to analyze. And the way it works is, they'll create fake services, right? Like, okay, here's a service that looks like an SSH server, or it looks like a web server, or it looks like a Confluence server. And then they look at all the traffic that's coming in. And they also try to differentiate between legitimate scans and malicious ones, right? So they have a database of scanners that are other security researchers, right? Like it's, kind of like that Spider-Man meme. Otherwise, everyone's pointing at everyone like you're scanning, but in the end, it's only security researchers. So they have a good database there. But this is not something that, like, a company wouldn't do that unless you're a security company and you have a product that makes sense, right? Like you're small, medium business or you're an insurance company, you're not going to build an internet-wide honeypot, or if you are, you've got like a security team that's got a really good budget and a lot of time, and I hope you make those results available. Most people won't do that. So what's more useful for a company is more of an internal honeypot, right? If you put honeypots on the internet, of course, a bunch of attackers are going to try to connect to it. It's on the internet, and when I say a bunch, you could try this if you have a Linux server with SSH on it. Connect that server to the internet and look at the logs, you're probably going to get connection attempts. I would say within a few seconds, but definitely within a minute, you're going to get connection attempts. It's the same thing if you have a Windows machine and you enable remote desktop on it and then you put it on the internet. A few seconds later, people will be trying to log in, right? So you haven't learned anything about like a targeted attack, right? It's just noise on the internet, right? People are scanning, and then if you're vulnerable, they'll exploit you and they'll try to drop ransomware at some point. But that doesn't really tell you much, because what are you going to do with that data, right? Like every time someone scans you, you're going to try to block those IPs on your firewall. That's going to be a never-ending chase, and you're going to end up with firewall rules that have a million entries in them. Plus, these scans sometimes happen from compromised systems that might be legitimate otherwise, so that you could be blocking legitimate traffic. So that's why we place them internally. And when I say internally, like here at Fleet, we don't really have an internal network, right? We work from home. I'm not going to send a bunch of honeypots to your houses, though that could be a fun project. It's not really scalable. But that could be within like a cloud environment that we have, right? Where we run our own dog food instance. We could run a honeypot in there that's not exposed to the internet, but that's exposed to our own Fleet servers. That way, if someone compromises a Fleet server and tries to scan the system and detect like what else could I connect to, then we'd be able to catch that. And so in a traditional company, you'd put those on your office network and then in your data center. Then you'd make sure that things like your vulnerability scanners, for example, are excluded from generating alerts, right? Because these things will scan the whole network. And then you expose the same services that you use internally on those. So that could be like, oh, I'm going to create a fake file server with fake shares, and I'll see who tries to connect to that, right? Well, that might just be someone curious while browsing, they saw it, or that could indicate someone that's scanning the entire network. Or I'm going to put something that looks like a old version of a web server on this important that looks like on something that looks like an important server, and I'll see who's trying to connect to that. And there's different tools to create those types of honeypots. I think the best known commercial one is made by Things Canary. So that's like a super simple honeypot to build. They ship it in either virtual machines or like an actual device. They have an open source version of it, which I think is called Open Canary, which you can find on GitHub. And then there's like old school projects like Honeyd, that's probably like 10 years old at this point, at least 10 years old, probably way more than that, or Kippo, and there's a bunch of open source tools, right? So the idea here is you want to build something. The danger is if you build something that actually is unsafe or vulnerable, well, you could shoot yourself in the foot, right? Like if you're creating something that's all too weak and then your honeypot has access to other parts of your network, that could be dangerous. But if you're using something like Open Canary or Things Canary, then you would just go and say, okay, I want a fake file server on this IP address. I want a fake print server here, fake SSH there, fake web server here, and whatever. And then you just look for the alerts. And the advantage of that is it's usually very low volume in terms of alerts once you've configured it properly. So the signal to noise ratio is really good, right? Because imagine you have a server on your network that no one has a reason to use, right? Like nobody even knows it exists. It's only there with an IP address. If someone is scanning for it, well, that might be someone scanning your network for legitimate purposes. But when someone tries to connect to it repeatedly, that is starting to look suspicious, right? It could very well be like a systems administrator who's wondering, like, what the hell is this thing? If they don't know about the honeypots, and that in that case, it's not malicious. But once people are informed, then you're going to get a really good signal to noise ratio. But the same concept of honeypot can be used to a lot of different things, right? So traditional honeypot is about exposing network services, right? Like, oh, here's a Windows remote desktop server, and if you manage to connect to it, we'll log that and we'll alert. But you can do a lot of other honey things, right? The spam filtering industry has been using that for decades, right? It could be servers or even just like email addresses that are not really used for legitimate purposes, but they're used with a bunch of different services. You post them in different places online, and then you see what email you get to it, right? If you never opted in to receive any email, then by definition, everything that you receive is spam. And then you can use that to train some filters. So that's a concept that's been in use for a very long time. Then you have honey users. So a honey user, like a honeypot, is like something, well, in this case, it's something that looks like someone instead of looking like a legitimate service, right? So we've got a bunch of employees at Fleet, but we could create in our systems something that looks like a real employee, right? Like with a name. Everyone knows that they're not a real employee, but we don't necessarily write that everywhere, right? So let's say Guillaume Ross is not a real person, right? And I exist in our Google environment. I exist in a bunch of different places. If you see someone manages to log in as a person who doesn't exist, then you have a big problem. Credentials have leaked, right? Because you made the password that long when you created it, or you made it like relatively hard to break. and then it was never used. So if someone is suddenly able to use it, you definitely know like someone somehow broke in or managed to reset the password without the appropriate information or bypass some kind of process. So that would be a Honey user. Then you have also multiple types of Honey data. So that's the thing that matters in a lot of breaches, right? You want to know if your data was compromised, or in the case of ransomware, if it was compromised and then encrypted. That could be files or could even be data in a database, right? So for example, if I created a file and put it on let's assume we had like a file server, or it could be Google Drive or whatever. And I put a file there called Fleet 2022 employee social security numbers.xlsx, right? So, well, maybe an attacker who's interested in stealing social security numbers for identity fraud purposes might download that, right? And if they download that, well, we could catch that through logs, right? Like if it's a Windows, if it's a Linux system, especially with, let's say you have a file server that's running on Linux, you could use OS Query and Fleet to do file integrity monitoring and to watch for these files, right? You don't want to be alerted when people read every file, but these files that you've created that contain fake data, you just want to see, is anyone reading this? That's not like the backup process. And if so, that's something that I want to know about, right? So if you're using OS Query, you would use the file alerts, the file events table with the file integrity monitoring. And then you also have Honey credentials, which would be other types of credentials, right? So we use AWS at Fleet, and so AWS uses AWS keys. There's a bunch of services that use API keys, right? So what you could do is create keys that are real but have no access, and then you sprinkle them in places where an attacker would look, and then you monitor for activity, right? And you don't put them in somewhere that's too obvious, because then you're only going to be generating noise, right? So if we put AWS keys in our GitHub, which is public, because we're open source, 1 million people would be trying to log into our AWS to spin up like GPU instances to mine, whatever is the hot cryptocurrency of the day. So recording this on June 14, maybe 2022, maybe that's a little less popular than 3 days ago, but that would generate too much noise. So you put that on something that's more internal, and then you just watch for people using them. So those concepts, like you can honey anything, right? Like you can, what did I say the other day? Like everything's edible if you chew hard enough. Anything can be made into a honey thing if you have enough imagination for it. So a good example of that is, again, thanks, because they're open source. They have other open source tools that you can use. One of them is Canary Tokens. So tokens are essentially a way of getting notified about activity that relates to different types of files or different types of tools. So for example, you could create a Microsoft Word or Excel document, put real data in it, but there's a tracker. So think of like the advertising, the pixel image tracking you've got in emails that advertisers put an email to know if you've opened the email and what your IP address was and all that. It's using those techniques, but for defensive security purposes, but they go way beyond just the pixel tracking. So for example, if I open this Word document, which I did a few minutes before our call, I opened it from my home machine, and instantly I got an alert saying, hey, someone opened up that Word document, right? So that's super useful if you sprinkle real file servers with these types of documents that people would never open. And then you get an alert when someone does, right? That means someone's on your server, and then you know their IP address. How does it know the IP address? Well, similar to pixel tracking, but it even goes further than that, where let's say I open that Word document on a system that is firewalled from the web, right? Can't go to the web. I wouldn't have known my full IP address, but I still may have received an alert because it uses DNS for exfiltration. And so as soon as you have, when you set up Canary Tokens, you build your server, you need to give it domain names that you only use for this. And for all of these tokens, it's going to generate a host name that is never going to be used for anything else, right? So you see my Canary token in the slide here that starts with Y and ends with C. So imagine if that was like YTXL blah, 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 dot, fleethoneypots.com, right? You'd never call it Fleet Honeypots because then it's obvious it's a honeypot, but it's a host name that no one will ever connect to. But if you open that file in Microsoft Word, your computer will try to resolve that. And even if you don't have full access to the internet, that DNS request will go to your local server if you're in an office, and then it will go to the actual name server that manages that. So you can still know it was open, even though you don't know exactly from where. So if any of you want to try and open that Word document, you can do that. I'll show you screenshots after we're done recording. And then there's a bunch of other types of tokens you can use, like you can create fake VPN connections, right? Like WireGuard VPN. So a lot of companies use VPNs to protect supercritical networks. Well, what you can do is on your DevOps engineering team's laptops, put a few different VPN profiles. One of them is the real one. Some of them are fake ones, but you have really high alerting on that, because if someone broke into your engineers' laptops and stole your VPN connections, you want to know right away. But monitoring a real production VPN where 1,000 people connect is harder than monitoring one where no one is supposed to connect, and suddenly someone has the right credentials to connect to it. So that was a really quick overview of what honeypots are. If you're someone from the community watching this, make sure you drop into our Slack channel. You can see the URL for that at the bottom right. If you want to discuss Fleet or honeypots in general, or also I mentioned file integrity monitoring earlier, which is a really effective way of tracking what's going on file servers, for example, which you can use for honey data purposes.